Hi there, welcome to another session of math problem solving. So here's today's problem. In the square below, the small circle just touches the four larger circles. Calculate the area of the small white circle as a fraction of the entire area of the square. Now this is a medium level Olympiad problem for typically say grade 8 to grade 10. It's not very straightforward. It's a strongly application based problem. There's no formula for you to just pop in and get the answer. It's definitely non routine. So it ticks all the boxes required to think from first principles to solve this problem. And it also shows how important it is to know the first principles, to observe the problem, and be able to connect the dots and therefore apply the principles to solve the problem. Okay, so the first thing I would observe is to say that there's an assumption that the side of the square would be known, implicit assumption, because you're trying to find the area of the circle as a fraction of the area of the square. The area of the square is going to be calculated based on the side. So you can basically assume that the side would be x. Now, if this is x, then you also see that the circles are stacked up in such a way that two diameters would be x. And the diameter is nothing but 2 radius, which means 4 times the radius. So to make things simpler, instead of dealing with all the x's and d's and r's, you could say that the side length is 4, giving you a radius length of 1. But how does this help? Because what we are looking for is the radius of the inner circle. So in order to do this, we can think of, okay, how do I bring in the inner circle? How is it connected to the rest of them? And the problem right now is that even if you were to draw a diagonal whose length you can find out, because if the side is 4, then the diagonal would be 4 root 2. And you know that this is 2 and this circle has a diameter of 2, and this would be like 2 times r, or 2 times a, let's call it a, 2 times a. So a is the radius of the smallest circle, so 2 times a. But the problem arises because you have this length beyond the circle, this part and this part, which is unaccounted for. There's no way of figuring out what that length is. And therefore, just blindly trying to say, okay, I'm just going to take the diagonal, extrapolate it, and solve it is going to be a hard ask. So what else can you do? So one possibility is you can think of all these 4 circles to have a center. So if you were to connect the centers, it would be fair to say that this is going to be a square as well. And the length of that square, or side length of that square, is going to be 1 plus 1, 2. Okay? So you have 1, 1, 1, 1, 1. Which means if you were to connect this diagonal out, that diagonal would be 2 root 2. And it would comprise of this radius plus this radius, which is 2, and 2a. Therefore, 2 plus 2a would be equal to 2 root 2. So in other words, dividing entire thing by by 2 would leave you 1 plus a is equal to root 2, or a is nothing but root 2 minus 1. So that's the area of the circle, which means the area of the circle, the small circle, would be pi times root 2 minus 1 whole square divided by the area of the entire square, which is 4 square. So that's 3.14 times 0.414 whole square divided by this. So you can calculate the value to arrive at the numbers. But I would like to leave it in the abstract, saying pi root 2 minus 1 whole square divided by 16. This is the ratio and the answer to the question. I hope you found this video useful and the method of solving using first principles to be something that you can apply in other problems that you solve. If you did like it, please do share, like, and subscribe to Buffalo. Thank you so much.